In this video, we're going to talk about an operation on functions called function composition. So function composition. So if you have two numbers, like 1 plus 2, you can add them and you get 3. You can subtract them, you can do 1 minus 2 and you get negative 1. You can multiply them and you get 2, and you can divide them and you get 1/2. So given any two numbers, we can add them, subtract them, multiply them, and divide them. You can do the same thing with functions, right? If you have f of x equals x and g of x equals 1 over x, I can add them, so I can do x plus 1 over x. I can subtract them, x minus 1 over x. I can multiply them, x times 1 over x. And if I really wanted to, and I don't, you could divide them. You could do x divided by 1 over x. So with numbers, you can add, subtract, multiply, and divide them. And you can do the same thing with functions. You can add, subtract, multiply, and divide them. But then there is another operation that exists, and it's called function composition. Okay, so it's another operation. So given two functions, we can combine them in a certain way or compose them, and we get a new function. So if we let f and g be functions, then the composition, so the composition of f with g is, it's called the composition. The notation is an O, like oh no. So it's f o g, then parentheses, and then of x. So this means compose f with g. So basically this means you put g into f. So it's f of g of x. So you put g into f. So whatever is here goes into this one. Let's do an example so you see how simple this is. Actually, it's not that simple. I shouldn't say that. This is probably one of the hardest things for people to learn when they first see it. So say we have f of x equals x plus 2, and then g of x equals 3x. Let's compute f o g of x. So this means that you put g into f. So it's f of g of x. Okay, so you put g into f. And so now what you do is you replace g with what it is. So g is 3x, so it's f of 3x. Right, so you just do a replacement. And then now this is telling us to look at f. So f is x plus 2. So f of x is equal to x plus 2. This is our x, this whole thing here. So instead of x plus 2, it's 3x plus 2. Right, because that whole thing there is our x, this whole thing here, this thing in a box, right? So it's blah, right, plus 2, right? Because that's what f of x is. It's f of x plus 2. You can think of it as f of blah. So it's blah plus 2. That's how I think of it. I just think of it as a thing. Let's go backwards. Let's do g o f of x. This means you put f into g. So it's g of f of x. Okay, and then this means now we look at little f. So f is right here, and we know that's x plus 2. So first you put f into g, so it's g of f of x, and then you work from the inside first, so that's our f. And now we're supposed to look at g. So g is right here. G of x is 3 times x. So this whole thing here, this is our x. So it's just 3 times x, or 3 times x plus 2, because that's our x, that whole thing there. That's what g does. G takes blah and multiplies it by 3. So this is 3 times x is 3x, and then 3 times 2 is 6. So that's function composition. In the videos that follow, you will see many more examples. I hope that helps.